So this is the third video for our biodistribution pipeline. In the first video, I explained to you how to create the scan folder structure, the cropping file pipeline settings, and how to perform the multi-subject cropping batch. In the second video, I showed you how to create the atlas file to then run the AI tools for automated body, organ, and tumor segmentation. And in this third video, I would like to explain how to compute the biodistribution curves in batch mode, for example, for %ID, how to adjust the intensity of selected classes on the selected layer to remove the bed, and how to save 3D screenshot series and also batch mode for a nice presentation or publication. Okay, so we will go on in our sorted folder. And last time we created the body and organ segmentation, and based on that we will compute the biodistribution curves, and I will start with the body. So I open the underlay and drag and drop the body segmentation and also %ID, as I want to show it to you in %ID, but of course you can also load the overlay, what would be here becquerel per ml or SUV, but I will drag and drop the %ID overlay. Change here to overlay, very important, because your biodistribution curves will be created based on what you select here. I will activate the batch settings, update settings, activate, and then I will go to batch compute biodistribution curves. We just have to change here the target file name. For example, it could be batch statistics %ID body %ID, and we run that. Then you will see that for every mouse there is an XLSX file for the batch statistics. So for mouse 1, 2, 3, also 4. And when we open that, you will see that you have now the %ID for the 3 different time points, 1, 4, and 24 hours. You will get the volume, the mean %ID per ml, and the total %ID per ml. You will get a nice curve also for the volume and the curve for the mean %ID per ml. You could also, of course, adjust the graph, or you can just copy paste the data in GraphPad Prism or any other software you would like to use for the statistics. Yes, then we will do the same for the organs. So I will now drag and drop the organ segmentation file. Yes. And %ID is still in. So I need to update the batch settings, because here you still see that this is the body segmentation file. When I now update, it will change to the organ segmentation file. Underlay %ID. So activate it, that's fine. And I will again go to compute biodistribution curves, change the name, for example, batch statistics, organs, %ID, and run it. And you will see also here there will be a file that now named batch statistics organs %ID. And when we open that one, you have now all the different organs like bladder, heart, kidney left, kidney right, liver, lung, and tumor for the 3 different time points. And you again get a nice volume curve for all the different organs and the mean intensity %ID per ml. You see there's a lot of signal in the bladder. So here we could now remove the bladder just to see the other organs. So here, for example, kidney left and right, and the other organs. And also here you could adjust the table min-max values and so on, or just transfer to any other software. Okay, that's how you could create your biodistribution curves, in this case for the body and organs and tumor. And now I would like to show you how you can remove the bed. So I will close that and open the underlay again. We will use the body segmentation for that and activate the batch settings again. Then under batch, you can go to batch operations and to adjust intensity of selected classes in batch. The target intensity will be -1000, that's right. And the target file name we have to give, for example, we can name it CT cleaned and then .gff. You need an ending here, otherwise it will not work. And you need to select the class that you would like to remove. So everything that is body will be kept, and everything that is unclassified, like the bed, will be removed. Run it. Then you will see it creates a CT cleaned file also for all of them. Then we do the same for %ID. So just close that, load the %ID, change to the overlay, update the batch settings. As you can see, it's still the underlay. When I update, it changes. I mean %ID here. This is now added. Okay, then I go again to batch operations, adjust intensity of selected classes in batch. Now the target intensity is 0, that's fine for the overlay here, and I will name this %ID cleaned, also .gff. Again, select unclassified and run it. As you can see now here we have %ID for all of the folders. And also here, of course. So %ID, cd cleaned. Okay, and when I now close this and open the cd clean file, you can see now the bed is removed and you have a super clean CT scan here without the bed. We can also now overlay the %ID cleaned. Okay, I will just close the 2D view and I will adjust the windowing a little bit for the overlays of %ID. We'll change that to max 10, so min 0 and max 10. That's now a lot of signal in the first scan, so in a 1 hour scan, but it will go down, of course, for the 4 and 24 hour scan, so if you have more, even there. And what I would like to do now is to save the 3D rendering here, to then create the 3D screenshot series for all of them. So just to do that quickly, I will have it like that. Just put it in the middle a little bit. Make the window a little bit smaller, for example, like that. Mouse a little bit bigger. Use the plus sign here, for example, as a middle. So the smaller you make the window, you can also make it small like that as you wish. Then everything else around is also cropped and you don't have so much area around. Then I will go to save image, save screenshot, and save it, for example, as 3D rendering. And this I will do quickly for every mouse. So I will just update the batch settings, go to the next one, then it's the same %ID, so it will stay at 10% ID. Save, 3D rendering. Next one, save. So just adjust that a little bit that it will look nice at the end. Save rendering. Next one. I'm just always using the plus sign here as orientation. So next one. Okay, the next one. You see already there's quite a nice signal in this study in the kidneys and also in the subcutaneous tumor here. Okay, almost at mouse 3, 4 hours time point. Save 3D rendering. Next one. So always mouse 4, first hours time point. If you have something like here, you could also remove that. So save. Next one. Okay. And the last one. So, And when you have saved all the 3D rendering for every mouse, you can then go to batch. Of course, you need to activate the batch settings, already activated. Go to batch and open 3D screenshot series. Then you select one of the 3D rendering PNGs, open, and save screenshot series as an image. Just do that. Batch, 3D rendering, add 10% ID. Okay. And when you then go to the folder, you will see that here. And when you double click on it, you then see all the mice for the different time points. So when I just zoom in, mouse 1, 1 hour, 4 hours, 24, mouse 2, and so on. And so you have a really nice overview of all the different mice quite quickly and nicely arranged. And you really see the biodistribution quite nicely. So in this study, a lot in the kidneys, but also in the subcutaneous tumor here, and of course in the bladder. Yes, so this is the last step of our biodistribution pipeline here. And yes, have fun and goodbye.